Hello and welcome to my new series where I'm recreating AI generated videos using Houdini until AI gets good enough to take my job. So for today I chose this video of a Rolex which I found on the discover page of Midjourney. And first let's see what AI did right, what AI did wrong, and where can we improve before we start working, and I'll show you how I recreated this. So first of all, let's start with the obvious. The Rolex logo is it's not okay, and I'm pretty sure that even the most junior brand manager at Rolex would not be okay with something like this being posted anywhere officially. Second of all, really weird, the minute hand is really short. Also the crown has a weird flicker and it's missing the crown, the Rolex logo. What else can I see here? Oh, the date has 3 digits instead of 2. That's really weird. What else? Okay, I think other than that, this is honestly pretty solid. I like this wispy smoke effect slash ink in water effect. That's pretty consistent and kind of good looking, and I'm sure we're going to have a bit of a challenge recreating this. Another thing I don't like is the animation. I feel like the Rolex should start turned away from the camera and turn towards the camera, not the way it is right now. Also, I think there's a bit of a noticeable ease that's kind of weird, like the watch is first really slow and then it sort of accelerates in a weird way, so maybe we can improve on that also. But yeah, I think also the lighting is pretty solid, so let's see how can we improve this. First we are going to need a 3D model, and I'm too lazy to model this myself, so I found this model on CG Trader that's pretty accurate to the real one. Let's do a quick comparison. Yeah, this looks pretty accurate to me, and for 27 bucks I think it's just a deal for a Rolex, so we're gonna get this and work with it. Let's check the topology and everything. Okay, yes, this seems fine, so I'm going to get this and let's jump into Houdini and show how I'm going to recreate this. Okay, so here we are in Houdini. I have the watch imported. Let's see. Okay, let's actually move this to the origin. Let's check the scale. Okay, so this one is huge, so let's actually scale it by 0.05. okay, now this is way better, and now let's examine this a bit. Okay, so the first thing I'm seeing is that this is going to need some subdivide. So let's add a subdivide node. Okay, let's say 2 layers. Now for rendering, I think we are going to use Redshift. So let me add a Redshift light dome. Let's quickly add an HDRI to this one. Okay, let me disable it in the viewport. Let's add a camera. Okay, and let's launch the IPR and see if there's anything weird with normals or stuff like that, and if everything is okay, let's just start shading this. Okay, so it looks fine. So I guess what we'll need now is materials. So the way I'm usually doing this is I'm having a material network inside of the object network, and here I'm keeping all the materials that are related to the object, and then I'm using groups in order to assign those materials to their corresponding pieces of the object. So let's add as material builder. Okay, and I think I'll start with the glass because I want to see if everything is okay with the dial and everything inside. So let's push this one to 1. Let's call it glass. Okay, let me pause this for a bit. Let me add a group. We have a lot of groups already coming in with the obj, so let's clean those using a clean node. Okay, I don't want to remove the generate primitives, I don't want to reverse the winding, I don't want to remove unused points, I just want to remove all the groups, and I don't want to remove nans. Okay, so now it's easier for us to check. Okay, now let's add a material node and let's assign the material real quick. Okay, and now if we launch the IPR again and we look through the material, we can see. Okay, let me now go real close and check stuff on the dial. Okay, I think we have to remove the rough of the glass because I forgot to do that. So let's give it a tiny amount of roughness. Okay, and I'm already starting to see something weird going on there. So usually when I have objects like this, okay, so usually when I'm having objects like this that are occluding the way, but there's stuff behind them that can be seen because they're made of glass or anything transparent, what I'm doing is I'm adding a quick transform node and I'm just moving it out of the way. Oh, okay, so some of the geometry here, it appears that was not supposed to be subdivided, so you can see that our raw logo is getting close to the mosh that the AI was making, so we need to fix that. So let me, what can I do? Oh, I can only apply the subdivide on certain pieces. Okay, the glass looks subdivided enough for me. Let's definitely do the bracelet. Here and here. Okay, and now I guess we're going to have to do this selection again. Okay, so now the dial and dial markings and everything else looks good. I'll keep this transform around because it's going to be easier for me to assign materials on the dial with this, and I can always turn it off to check if the render is fine and then turn it back on so I can easily select, and I'm keeping point counts and everything while doing this. So that's one trick I'm using it when I'm having to assign materials to occluded objects like this. Okay, so now if we check the reference, we're going to need some kind of rose gold, some kind of, here in this reference is silver, but we are going to make this part gold. We are going to need a material for this white part behind the calendar here. We're going to need the black material for the indications of the calendar. We are going to need a material for those crystals, and another, I think the same material that we are using for the calendar indication we are going to use for this text here with the logo, the text down here, and those fine markings around here. I think the thing that holds the diamonds in place is the same material as the rose gold here, so I think we're going to have something like 6 or 7 materials, so let's just start making the group for those. Okay, so let's start with the rose gold. Okay, so now that we have all the groups, let's start working on our materials. So I'm going to grab 2 materials out of my library, rose gold and gold, and we are going to use these 2 for those parts. I have a glass material, let's duplicate this one, call it diamonds, and for this one let's increase the dispersion so we have that colored refraction thing that you see in diamonds. What else are we going to need? We're going to need a simple white material. Which is just going to be an almost white value here, and let's push the roughness really high. Let's duplicate this one, call it black, switch the color to almost black. Okay, do we need anything else? Let me see. So we have the gold, we have the rose gold, we have, oh yeah, we need the material for the tile. Okay, for this one we are going to increase the IOR to something like 5. Let's decrease the roughness a bit. We are going to see this in render anyway, but I want to have some sort of a base, and let's give it a shade of sort of pink. Okay, now let's assign those materials. So what I'm going to do would be to create a material node here first, and without any group I'm going to assign gold to all the pieces of the watch. So right now if we launch the IPR, everything is going to be made of gold, and the first thing I'm seeing is that the normal on this gold is really intense. So let's go and quickly fix that. Okay, this is way better. And now that we have gold on everything, we can start assigning on top of it the other materials. Let me rotate that HDRI a bit. And let's also move the camera a bit. Okay. Oh, one thing I forgot is that I didn't add the bezel to the rose gold material. That's why it's looking so weird. Now it's pretty hard for me to tell with this HDRI, and we're clearly not going to use this for rendering, so let me try a different one. Okay, this should be better, I guess. Okay, now the dial seems a bit too pink for my taste, so let's really calm that down. Let me rotate the HDRI some more. So here's what we got in terms of animation. I'm pretty happy with this, because we only want this slow move for the render, but then we want this quick move in the beginning for collisions. So with this figured out, let's start and see how we can do the wispy smoke. Now for the wispy smoke, I took some time off camera in order to figure out the best way to do this. So this is what I came up with. First of all, I'm just importing the watch with an object merge here. I'm adding a null so I have a quick way to find it, and then I'm having a VDB for collisions. Okay, pretty straightforward stuff. Then here I have a box from which I am emitting only density with a volume scatter, so the whole box gets filled with points which have a value density of 1. Then I'm using a volume rasterize in order to turn those points into a volume, and then I'm having some noise in order to break up that volume. Now in the .NET, it's also pretty straightforward. I'm using pretty low resolution, only 0.025 voxel size, which gives us roughly 2 million voxels, which is not a crazy resolution, but that's not important because you'll see how we are going to render this effect. So this is pretty straightforward. I'm using the sparse solver. I'm having the watch here as a collider using volume sample. I'm sourcing density here and only density with a source scales of 0.1, so we don't have that much smoke in the scene. And then here I've just added some turbulence, and I played with the swirl size, the levels, and then I just tried a few seed values until I found one which I like. Okay, after that I'm just reading those volumes. I'm also reading the velocity volume, this is important here, and I'm caching both of those here. So if we're taking a look at the cached volume, let's see, but first let me switch this to dark so it's easier for us to see. Okay. Oh, and one other thing I forgot to show you is that I have animated the time scale. So here on this pre-roll of 30 frames, it's set at 1, and then from 0 on it's on 0.1, so we have this sort of time warp effect. Okay, so this is what we have in terms of pyro simulation, but with pyro we can't render this sort of wispy smoke effect. So in order to get that look, I'll show you a trick, which is to scatter a really large amount of points on the emission volume. You can see here we have 40 million points. Then actually we don't need this anymore, this is something else I tried, so we're not going to need that. Okay, here I'm converting the velocity VDB, the velocity volume from the simulation into a VDB, and then I'm using a vector merge, so we have, you can see here we have 3 volumes for velocity, 1 for each axis. And what this node does is it converts it into a vector volume which has all of those separate channels, 1 for each axis. It has them merged together. Here I'm deleting everything but density, so we only keep the density volume here. Then I'm doing a VDB analysis and I'm calculating the gradient of that density. Then we plug all of those into a solver, and in the solver we only have two VDB advect points. One is advecting using the velocity from the pyro simulation, and the other one is advecting using the gradient. So what this does is it helps the points stay closer together, because the gradient is going to push the points closer together in areas of greater density. And I can show you this on a smaller amount of points so you can understand exactly what's going on. Okay, so here is the effect, and if we are not using the gradient and we only advect using the velocity, you can see that the points are much more sparse, much more apart from each other compared to here, where you can see they are packed somewhat closer together. This is subtle with this amount of points, but as you go into the millions of points it gets much more evident. Okay, so why use this and not use, like, for example, a pop network and advect with that? The main reason is that the VDB advect points is really fast, especially when you are using like millions of points. So you can see here with 40,000 points it's quite fast, but if we push this to 40 million, okay, not 4 million, 40 million, and I switch this back to 0, you can see that while it's not real time, it's really fast. And here is another trick: when you have like advected points like this in the millions, it's going to be a lot slower for the computer to go to the HDD and just grab those compared to simulating them. So I would suggest you not to use any kind of cache and just have an output here straight from the solver. And this is what we have for the Wispy smoke effect. And now if I show you that in a render, okay, so here as you can see, we got the desired effect. Those points advected by that volume, which is pretty low resolution, and then rendered really small with this set to render object as particles, and then having a really small scale here. Like for this scene scale, for example, I'm using 0.00005 or something like that. I'm not sure which this number is, but it's a very small value, and you'll need to experiment this depending on your own like scene scale and stuff like that. Now we only need to do some lighting, and then I think this is good to render. So for lighting, let's add a backdrop real quick. Let me also rotate the HDRI a bit and see how this looks. I would like it to give more of some sort of a backlight. Okay, something like that. Now let's also give it a bit of a tint, so it matches with the backdrop. And now let me also add the light from above. Okay, something like this. And now I'm pretty happy with this maybe this is still a bit overexposed here, so maybe calm that light down a bit more. Okay, and maybe just maybe warm it up a little. Something like this. And now let me turn on the smoke and let's do a quick test render, and if everything is good I'm going to send this on the farm and then we're going to take a look at the result. I'm pretty happy with this result. Maybe I'll do another tweak or two to the lighting and to the materials, and then I'm going to send this to the farm, and when it's done we're going to check out and see the results. Here's the results side by side with the AI video. Two things I would improve from this would be the lighting, which is a bit flat compared to the reference, and also I would mess with the seed of the smoke a bit to maybe cover this area too and not have this much smoke in front of the dial maybe, but other than that I'm pretty happy with this result. And unfortunately for the Patreon supporters, because this watch was from CG Trader, I will not be able to share this whole project file, but I will share the Wispy smoke setup so you can take it from that heap and use it in your own projects. Thanks for watching, let me know in the comments what you think about the results, and I'll see you in the next one. Bye bye!